Hello and welcome back to the lab. Today on the bench we have a behemoth of a slow scope. This is an HP 122A. For its size, here's my hand in front of the tube. It's absolutely massive when coupled next to my 7603. And the bandwidth is nothing to get excited about either. This is a 600 kilohertz bandwidth scope. However, this is back in the vacuum tube era. And one of the neat things about this, because it's such a slow speed scope, is it doesn't necessarily need probes. It has BNC banana jacks on the front of it. So I thought that was pretty neat and interesting. This is out of the HP world, and this does come to us by way of NASA. So, not sure what that means to anybody, but this was at a NASA lab somewhere at some point, which is always fun to get some government cast-offs. So, let's crack this thing open and take a look at it. We have not plugged it in yet. We have not turned it on. I have no idea if it works or not, but the case does need some help. It's a fair bit dirty, so we'll get that all cleaned up and go from there. The front panel, for its age, is in incredibly good condition. None of the knobs are cracked and broken. Everything's there. Needs a little bit of a dusting, but there's no deep gouges in it or anything. So, a wonderful repair candidate. And we're going to cut our teeth on this one in the vacuum tube scope section, because I have a few more vacuum tube scopes that are going to be really fun to get in front of the camera here in a little bit. So more is on the way. So let's get the covers off and see what we're dealing with inside. Always a good sign when the messages are right out in front. But it looks like, to get into this thing, 2 big screws in the back. And looks like the whole thing may slide forward. That is some beefy hardware. Yes, it does. Oh, the whole thing comes out of the chassis. Hang on a second. So this is going to be really interesting to get apart on the bench. The whole center scope section comes out. Let me reposition the camera. So the whole center section comes out. I'm going to pull this off the bench and get the scope portion back up. I do not want this falling and dropping. All right, here we go. Scope's out in all its exciting high voltage goodness. It's not 100% tube. I do see a few transistors in here, which I was not expecting. We have a fair bit of tubes on the side. Here's the inputs with the attenuators. All the adjustments are going to be right here. CRT's obviously in the center. Power transformer in the back. We'll see what we have underneath, see if there's anything we need to worry about replacing or anything like that. Let's see, tube-wise. Looks like we have some HPs, we have some Telefunkens. Appears to match in terms of the 2 channels, so we may have a factory set of tubes. Let's tilt this on the side. Oh, we have parts. This is where we're going to do a lot of the work on this thing. Here's a quick view of the underside of the chassis. Lots of high quality parts under here. I am not seeing a lot that concerns me, to be honest. Mica caps. Not much paper. Hardly any paper at all, actually. No, not seeing a lot. Lots of precision resistors. Everything looks really good and really healthy in here. Hardly any corrosion for its age. Everything looks good. This may need some light servicing, but not much. The high voltage supply was all ceramic caps. Here's looking down the top on some of the high voltage section. The high voltage supply is actually on the back side of this board, but we have a high voltage transformer hiding out underneath here. And all these caps look in really good shape. Again, I'm not seeing anything that might need to be replaced immediately. I do want to check the power supply rails for ripple, but everything is looking so good in this scope that if the ripple's good, I may let it ride and just see what happens. This thing is in incredible condition for its age. Here's a look at the far side with another. This is the horizontal sweep attenuator block. This is probably. Would this be when they were doing individual settings per range? Possibly. These capacitors could be setting timing. I would think so. That's why there's so many adjustments. Switches are going to need a little cleaning. It's a little crusty, but not awful. I do have one concern, tube-wise. So we may have to dig out the tube tester. This guy right here. This 5651 looks like it might be a bit worse for wear. So this one may need some testing. Have to see what V310 does. Everything else looks okay. Don't see any chalkiness, or none of the tubes look like they've gone gassy or anything, so everything looks to be in good order. This might be safe to power up. Well, after checking with some data sheets, this is what a 5651 is supposed to look like. So it looks like it's already it's okay in good shape. I think we're going to be safe to try to fire this up and see if we get life out of it. Okay, you guys watch the tubes, and I'm going to turn on the power supply. I have it on the dim bulb tester. We're going to bring it up to about 30-ish volts. And we will turn on the scope. All right, we're drawing about 10 watts. Nothing crazy at 30 volts. Bring it up to about 60 volts. And we're just going to let it sit. Still don't have any activity on the bulbs, which is good. I have all 6 bulbs switched in, so it's got about 3 amps of current limit. But we're going to let this just sit for here for now, just to give the capacitor some time to adjust, let them get used to seeing voltage again, and I will bring you guys back in about a half hour or so. Nothing has happened so far, so time to dial up. We'll bring it up to 90. So I got 85 volts going into the scope because it is the dim bulb started to glow a little bit, but they're not bright, and we have some tube action. I see filaments lighting up. Let me move around to the front of the scope just in case something exciting happens. All right, keep an eye on the tube, see if anything happens. We're going to go up to 120 volts. It's 125 volts on the variac, and we're going to hit the bypass switch. We're at 90 watts right now. Hit the bypass switch. 133 watts. Well, that's better than I could have hoped. The trace is scrambled right now because there is no ground reference, and the chassis is open, so it's picking up noise from everywhere in the lab. So let me get it off of the isolation transformer and onto a correct 3-pin outlet. We'll see if that noise goes away. Modern rooms are just horrific for noise. It's awful. Okay, here we go. $138 and there we go. Nice trace. All right. I'm going to shut this off now, get this repositioned safely, and then we'll throw some signals at it and see what happens. We're going to have a little noise because the chassis is still open. Well, I can't complain about that. Magnifier's working. That's working quite well. We'll kick this up to 1 kilohertz. Let's check. We will add, we'll chop between A and B. Actually, we will alternate. I have some dirty switches. Well, that's looking a lot better. Oh, I need to bring that down a bit. There it is. There's the B trace. The A trace. Let's shrink the A trace. Shrink the B trace. Well, it's struggling a little bit with the noise, but it's locking pretty good. I cannot complain about that at all. I mean, it works. I got some switches to clean. That's B minus A, but it's a sine wave and a square wave, so it looks really weird. Our chop function. Is a bit cranky. Alternating's working though. We'll start with cleaning the contacts. So we have a little bit to troubleshoot in this scope. Going to dig up the service manual, see what the chop function, how the chop function actually routes, because that could be done about 30 different ways. So we'll see what the scope tells me, or the service manual tells me. Yeah, part of that's the trigger. So if I take it off of auto, it'll trigger on the base. Then I can get it to trigger on the top. I have this weird square wave thing going on that I can see in person. There, the trace area that shows it well. The trace is actually filling in between the top of here and up here. So definitely something in the chop circuit that might need some help. But that switch is dirty because just moving the knob gets it to go a little nuts. So that might clean up a little bit better. That might be helped with some cleaning. That is working way better than I thought it would for its age. So, time to dig out a service manual. Okay, after looking into the specifications on why the chopped looked a little funny, I realized I was pushing the chop circuit a little too hard. I was getting it pretty close to its maximum rated usefulness. The scope is a 600 kilohertz scope. The chop function is really only good to about 2 kilohertz, so at least according to the service manual. So above 2 kilohertz, the alternate function is what you're going to want to use. So the scope is actually working. I have it on the calibration signal, but I have the manual attenuators set down so it's not. I can raise it up and confuse it, bring it down, and confuse it a bit, but looks like chop is working okay. Probably won't use it much. I don't work on a lot of signals slower than a kilohertz or 2 kilohertz, so we'll go from there. Let's check the time base accuracy. I'll fire up the tech equipment and let's see how good the time base is in this thing. So in the HP manual, Tektronix equipment is called out for timing alignment. They do spec a 180 or a 184 in the alignment procedure. We're using a TG501, and I have it tuned up. But one of the things that's really interesting, if we take a look at it, there's not a fault here, and this really is a nitpick. I'm used to tech scopes, and this was one place where tech did a lot of R&D and getting this right. This is in spec, so everything is functioning as intended and correctly. The timing, unadjusted, I hit 10 time marks between 9.5 and 10.5 centimeters, and my actual sweep time is 2.5% fast for the scope on the 10 microseconds testing. The interesting thing on this is, if we look really, really close, we have a good time mark here lined up with the graticule. We have a good time mark over here lined up with the graticule. But in the center, we have a little bit of deviation throughout this range. So what that means is, while the sweep, full sweep, is relatively consistent and 2.5% fast, it's speeding up and slowing down. It's not linear. So the sawtooth that's driving the horizontal isn't a linear ramp. I understand the fact that I am nitpicking a scope that was made in 1960. But just an observation from what the time mark generator is telling me. Let's check 20 microseconds. I found out when the scope was doing this, my switch wasn't latched all the way, so that's going to cause problems. So we still hit in spec, and I'm still 2.5% fast, but now this range is running a touch slower. Using a camera as the guide. We'll judge the time marks from here to here. 10% and 80%, same way a tech scope would do it. Now this one's only 1.3% fast, so on the 20 microsecond range we get even better. What does 50 do? As the time marks speed up. Okay, this one looks a bit off. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3%. 1.3% Let's pull it down. And I will play with the horizontal positioning. That gets me good time marks at 50 mic. So my linearity is good, but this would be out of adjustment. I would call this, I'd want to tweak this, see if I can get this closer. Because we'll give it the best chance we can. So as I slow the scope down, my linearity is getting better because the timing marks now line up. But this range at 50 microseconds is running 8.2% slow because that's what the time marks want to be. So that would need adjusting. So my 50 mic range is out. About our 100 mic range, what does this look like? Yeah, that is also slow. By quite a bit. That could also be a little bit of drift over time. This thing is, wow, about 60 years old. We'll drop another range. Yeah, everything is running 8.5% slow now. Now, see, when we get down to the 0.5 millisecond range, we sped back up because it's stretched out. So this is now looking a lot better. That's only 2.5% slow. So that would be in spec. So the 200, 150 ranges, we either have a bad leaky timing capacitor or something that needs to just be tweaked and adjusted. Okay, so the spec on this particular scope is a 5% time base. So some of the ranges are out, but some of the ranges are still very serviceable. And anything that would be 2.5% fast, 2.5% slow, well within spec for this particular scope. So no problems there. Well, a couple of the ranges are bad and need tweaked. Well, since we have the gear warmed up and we're testing everything, might as well adjust the 50 microseconds sweep adjust since we know it's out. And I would be willing to bet with the way these adjustments work, the 50 mic is also affecting the 100 and 200 because there is a 0.5 millisecond sweep adjustment, 50 microsecond sweep adjustment, and 5 microsecond sweep adjustment. So it looks like the middle one may be out a little bit, which won't be too terrible. The other tuning capacitors that you can see on screen are actually for the voltage divider. So there is a voltage input on the horizontal for this scope, and that is the 1 volt and 10 volt attenuation compensation. I can talk tonight, I promise. Here is our 50 mic. Oh yeah, that adjusts quite a bit actually. With a little bit of tweak to the compensation capacitor, everything adjusted exactly like it was supposed to. And we have plenty of range left. So let's check 100. Be willing to bet you this is better now. Much. Okay, I like it. That is now off by 0.5. 200. off by 0.9. So much better on the time base. The micas are stable. A little bit of drift in the tuning cap. Nothing to worry about. Everything is back to rights. And there's a bit of our 0.5 right there. That looks very, very well done. Not too bad. All three time bases did need some slight adjustment. All right, so what's next for this thing? Well, I need to clean all the switches, get everything all lubricated up and set. Clean up the chassis. It needs a good wipe down. But all in all, scope's in good shape. Everything dialed in on the time base at least. I have no idea if the vertical's good on the attenuators yet. I need to take a look at that, and I definitely need to clean the switches. But since we've had the scope on, I want to wait for all the capacitors to discharge, get out of there before we go poking around with fingers in high voltage. All right, we are ready to power up after a good cleaning of the knobs and switches, as well as putting a little bit of lube on the mechanics. So everything should turn a lot better now. Lab's running at 123 volts. We'll kick this on and see what happens. Positive going, A mode, internal trigger, auto. DC's fine there. Ooh. Let's see, getting some life. Oh boy. Okay. So on the HP, on the tech scopes, trace rotation is what it's labeled on the HP. It's scale. So we definitely have some problems there. Get this readjusted real quick. It's nice to have a rotation on the front panel on one of these scopes because, like what happened on the Heath kit that I did a while back, it did not have a trace rotation control, and I got the trace perfectly aligned in the lab. Easy way was using a grease pencil so I could adjust it when it was off. At least that's what we did it the second time. But the magnetic field in the lab can cause the trace to skew. The problem is if you move the scope in the lab, or at least especially when it goes 600 miles away, it's going to be different. It may not be bad, it may not be great, it is going to be different. That is a guarantee. So it's real hard to set the trace rotation and then take it 600 miles out and then have to set the trace rotation again when I get there. Let's see. Channel 1. Internal should be fine. We'll kick this over to the calibrator. Bring this down. Ooh, that's way off. So on the calibration function, when you take the, at least on this scope, when you take the sensitivity and go all the way clockwise, you should get 6 divisions of display on a square wave. We are getting more than that. So the gain adjust is down here. And let's focus this. Ooh, nice sharp trace. Very nice. Okay. We'll do channel 2 as well. Turn off channel 1. Channel 2 to calibrator. Also way off. I may not have adjusted channel 1 correctly. We will go back and check real quick because it is not a huge deal. Oh, so much nicer. So less crunch. No, channel A is not bad. All right, so let's put this in. Let's hook up my calibrator. I've had it warming up. And we've done a quick calibration with the internal calibrator of the scope. Let's check and see how accurate that is in the vertical, if it's still accurate or if it's way off. So we're going to go to 1 volt per division DC coupled. On this scope, that is that position. So this side is DC coupled, this side is AC coupled, and then you actually have a channel off, and then we have to make sure the verniers are in the calibrated detent, which they are. So this is a 5 volt per 5 volts of signal from a Tektronix PG506. Little off, but I am not unhappy about that. What's our percentage out? That's pretty much dead on the graticule, and I am not unhappy with that. Let me move you up there. With a quick and dirty alignment, the vertical on this 60-plus-year-old scope is 0.5% out. So I am very okay with that. Not one problem at all. Go ahead and check channel 2, or B channel. It looks to be a bit further out, but only 1.7%. So no problems there whatsoever. So I got the case cleaned up. Alcohol took a lot of the magic marker off. There's still a little bit on the side, but unless you get really close to it, it looks passable and presentable. So I think I'm ready to throw this scope back in the case. Let me know down in the comments if you guys think we should change any capacitors or anything like that, or because this is staying here in my lab, this isn't going to anybody, do we want to run it as is and see how it goes? We'll just see if there's any faults long term, because I do plan on using this scope for some troubleshooting of audio amplifiers, things like that, some lower speed stuff, with it only being a 600 kilocycle scope or kilohertz scope. I've been looking at the service manual. I've been dealing with kilocycles for the last couple of days. It's definitely not going to perform on the high speed side of the bench, but it's absolutely fantastic for some of the amplifier stuff that I want to do. And the bonus, it has balanced inputs, which is very rare on a scope. So definitely going to find a place on the bench and get ready to go. We do have some more vacuum tube scopes coming, so hang around. Right now, I'm going to get this thing put back in the chassis. Okay, we are back in the case and ready for some burn-in testing. All right, we'll let this sit and cook. Gonna turn the display down, but we'll give it a shot to warm up, do some burn-in testing, just let it sit, and see how it goes. Nothing happens. We'll get this one over where it belongs, or where we'll find a hole for it, and put it back to work. One thing I did notice, ever so slightly, the trace rotation was out when I put it back in the case. That's perfect. So just popping it in the case was enough to tweak the trace rotation just a little bit. Well, we're back. It's been a couple of hours. Everything's sitting. It's nice and warmed up. Still got a good power light, so that's a good sign. It's been drawing about 130 watts for a while. Nice 130 watt space heater. But Can't complain about that. And the sweep has stabilized, which is good. Let's see. So once the unit warmed up, now we are off on our gain setting due to warm up. So let's see what we can do about that real fast. This stuff is incredibly stable once it's warmed up, but it can move substantially during warm up. Also, take a note as to how balanced the tubes are. Bear in mind these CRTs are differentially driven, so you have a plate pulling and a plate pulling below and a plate pulling high in the CRT. So to have both traces line up this well, this is incredibly balanced and says a lot about the design and the stability of the design and things like that once it was up to temperature. So quite impressed with. And our chop looks like, yeah, it's not bad. With both traces off. I can't argue with that at all. So, all in all, I think we have a good slow speed scope for the bench. Not the fastest thing on the planet, but we have some plans for it. And it's working quite well, especially for a 60-year-old design. So thanks a lot for swinging by the lab and taking a look at this 122A 600 kilohertz scope from HP, circa of about 1959, 1960, I believe, if I remember correctly. If you liked what you see, hit the subscribe button, the bell, notifications, and hang around. As always, more is on the way. Patreons are running about 5 videos ahead from the YouTube channel. There is nothing behind the paywall at Patreon. Everything that is up there right now will eventually hit YouTube. But support to the channel is incredibly appreciated to those that have signed up to be patrons. And they help keep the lights on more than anybody ever knows. In between videos, I'll be in the comments section, hanging out with all of you. And I will see everybody in the next video. Bye for now.